Hey guys, what's up? It's Yari Darelli of Gen Zero. Welcome to the last lesson of programming in Objective-C. This is the last of a mini-series of 3 videos about Foundation, in which I walk you through collections. Collections are classes used to store groups of objects. In Objective-C we must make a distinction between mutable and immutable collection. In the immutable collection, the number of objects contained cannot be modified. Therefore, we initialize a collection with some objects, and if we want to change it, we have to create a new instance of the object. The mutable collection is a subclass of an immutable class. It has some more flexibility and can add and remove objects from its list. Every collection has shared features, so through the collection we can enumerate objects, verify the presence of an object, access individual objects, while with a mutable collection we can also add objects and remove objects. Collections of objects can be created in many different ways, depending on your needs. In this lesson I show you how to use the NSArray, NSDictionary, and NSSet class, and then I'll introduce you to a mutable version of these classes. Let's start with the NSArray. The NSArray is an ordered collection where any object is stored at a numeric index. We have many ways to instantiate an NSArray. Let's see some code. Okay, by calling the class method array, we instantiate an empty array, probably not really useful for this immutable version. So let's see how to create an array full of strings and numbers. Using the class method arrayWithObjects, we specify a list of objects terminated by nil. So let's add a string, writing @1, and now a number. To add a number into a collection, we must wrap it into the NSNumber class, as I told you a few lessons ago. So add an integer using the NSNumber and the numberWithInt method. And then remember to terminate the list with a nil value. Okay. The variable array now contains 2 objects, and we can check its size with the count message. Let's do it within an if. So I can write if array count greater than 0. I told you that a collection can enumerate its objects, so let me introduce the fast enumeration, a special use of the for loop. Let's see how it works. I write, for example, for object in collection, and then I do something with the objects. It simply enumerates every object in a collection, and for any loop it assigns the current element to the object before the in keyword. Now within the loop we can work with the current object. Well, there goes the first problem. Right now we have 2 different objects, a string and a number in the array. You probably remember that there is a generic data type called ID. So let's write the enumeration taking that element in consideration. So the object could be an ID, and the collection is the array we have just created. And now we can use introspection to be sure we are using the right methods depending on the object. Let's create a really simple case where we perform a different NSLog output depending on the class of the object. We use isKindOfClass to check the class type, and we output different messages depending on it. For the string, we'll write I'm a string, and for a number, I'm a number. Okay, this is not really exciting, but I think it's simple to understand. Let's try the code. Oh wow, it works. In the console we get messages created by the 2 array elements, a string and a number. Now let's determine if an object is into the collection or not. We'll do so by removing the if block and using the function containsobject this way. This function uses the NSObject method isEqual to find an object in a collection. Keep in mind then that if you create a custom class, you'll have to work on this override to perform comparisons and searches on a collection. Getting an element at a specific index is a really common task, and you can do that with the function object@index. Let's access the string by sending a message to the array and specifying the index 0. Compile, run, and you get 1. That is the first element of the array. When we want to get the last object, instead we can use the lastObject method. This is particularly useful because you can use it to check if an array contains any object. If it is empty, this function obviously returns nil. Now, let's see how the mutable version of the NSArray works. First, the class name is NSMutableArray. We can create an empty array using the same technique we have just seen. So we'll write NSMutableArray, array, NSMutableArray, array. And now we can add object to this array with the function addObject. The object will be added at the first available index, in this case 0. We can obviously remove the object by sending the message removeObject and passing the object that needs to be removed. As for the containsObject, the isEqual function will be used to find the right object to remove. And you can also choose to remove an object at a specific index with the removeObjectAtIndex method. I strongly suggest you to take a look at the full list of methods for NSArray and NSMutableArray into the official documentation. The next collection is the NXDictionary. This collection manages pairs of keys and values. Each element consists of one object that represents the key and the second object, which is the key's value. A key is a unique object, so there will never be two equal keys. Most of the times, a key is expressed by a string, but it could be also defined by whatever object fully implements the hash and isEqual methods. But for this course, we are just going to be using a simple string. Let's see how to create a dictionary with some values, and remember that Foundation gives you different ways to do the same thing. So, here we use the method dictionary with objects and keys. This function needs a list of value key pairs closed by a nil terminator. Now I define the first object, in this case a string, and the key for this object, in this case first. And then I define the second object, an NS number with value 10, with a key equal to second. And then I close with nil. Now the NS dictionary contains two values, and we could check it using the count message, as for the NSArray. But we can skip it, you know how to do that now. With this structure, we don't have indexes, like in the NSArray, but we can access the data through their keys. For example, we can get the value stored for the key first with this code. Let's use a string, and with the message object for key, we can specify the key whose value we are looking for. Now the variable object contains the string 1. Let's check it with nslog. And OK, we get the first object. The NXDictionary lets you get an NS array of all the stored keys using the method allKeys, and an array of all values with the method allValues. You can perform fast enumeration on these NS arrays and cycle the values stored in this collection. The mutable version of NSDictionary obviously has some methods that modify the collection. We can start by creating an empty dictionary with the class method dictionary. Now we can add an object using the method setObject for key, and remove the object using the method removeObject for key, again specifying a key. If the key doesn't exist, nothing happens. In case we need to remove every object, we can call removeAllObjects. OK, you can check the documentation to view a full list of available methods for NXDictionary and NSMutableDictionary. The last collection is the NSSet. This collection stores unordered and distinct objects. The mutable version has set capabilities like union and intersection between sets. Let's see how to use this collection. First, we can initialize the object starting from an array or from a list of objects defined in line. Here is an interesting behavior of the NSSet class. Let's say we want to create a set starting from an NS array. So let's create the array with some values. We use the function array with objects, and we use 3 strings, So for example 1, 2 and 1 again, and close with nil. Now let's initialize the NL set with this array, using the function setWithArray, and we can perform fast enumeration on this set. Let's use a string as current object, because we know that the set contains only strings, and then print the value of the current object. As you can see, the duplicates were removed. This is a property of the NS set. It can only contain unique values. Now let's move to the mutable version, this time performing some interesting operations. Let's create two sets using the method setWithObjects. The first set with the values 1 and 2, and the second set, set B, using the value 3, 4, and again the value 1, and close with nil. Then create a mutable empty set using the method set. Okay, now we can perform some operations. Let's start by performing a union with the set C and the set A. Let's create a fast enumeration and see the output. As you can see now, C contains the same value of the set A. Now we can perform an intersection between the set C and the set B. Okay, compile and run. And you can see only the values which are present in both sets. Okay guys, this is all for this last lesson. I hope you have enjoyed this course as much as it was a pleasure walking you through these topics. So thank you so much for watching till now, and thanks to Envato team for this great opportunity. Let's keep in touch.